Hey y'all, welcome to Miss Clarke's chemistry class. This is the first lesson on a series of lessons about oxidation reduction reactions. This lesson specifically, I am going to answer the question, how do I label oxidation numbers? How do I assign oxidation numbers? It's a little bit different than what we've learned in the past. So go get your periodic table, get something to write with, and let's get started. This is going to be just the basics. What is a redox reaction? How do we assign all these different oxidation numbers? We think we know how to assign oxidation numbers, but there is actually more to it. Okay, so I keep saying this term redox reaction. Well, really, redox is a shortened version of oxidation reduction reaction. Yes, I realize the order got switched up, but I guess redox just sounds better than oxred. Let's get a definition for oxidation reduction reaction. Now, at the most basic level, a redox reaction is where electrons are exchanged. An oxidation reduction reaction is a reaction where electrons are exchanged. Let's get a little bit more specific in that definition. The electrons are exchanged from one element to the other. So one element will lose its electrons, and one element is going to gain electrons. When that element loses electrons, that's called oxidized. And when the element gains an electron, that's called reduced. So if that brings us down here to these other letters, RED for redox, that means reduced. And an element is reduced when it gains electrons. And then ox means oxidized. And an element can be oxidized when it loses electrons. Now I've got a good memory helper. I've got two separate ones. Here's my first one, oil rig. Oil rig, OIL stands for oxidize is loss. And rig stands for reduce is gain. Okay, so that's one memory helper, oil rig. Oxidize is loss, rig, reduce is gain. Second one is Leo the lion says grr. This is probably the one I go to the most because I feel like this is the one I was taught first. Leo the lion says grr, where Leo, loss of electron, is oxidized. Same information, grr, gain of electron is reduced. Because it's really important that you know which elements of the reaction are being oxidized and which element of the reaction is being reduced. So hopefully one of these two memory helpers will help you. Oil rig or Leo the lion says grr. Let's keep going. So when an element is being oxidized, that means a couple of things. Number one, it's losing electrons. To visualize that though, we're going to have to look at its oxidation number. And if you're losing electrons and electrons are negative, then it's becoming more positive. So when an element is being oxidized, its oxidation number is going to increase. Its oxidation number will increase. So for example, if we have sodium plus 1 and that turns into sodium plus 2, to make that jump from plus 1 to plus 2, it had to lose an electron. Is that making sense? Sodium is number 11 on the periodic table. In this instance, it has 11 protons, and right now it only has 10 electrons. That's where we're getting this plus 1 here. So for it to go to plus 2, it had to lose another electron. So this sodium would also have 11 protons, but this time the electrons are going to only be 9. That's where we're going to get that plus 2. So when elements are being oxidized, they are losing electrons, but their oxidation numbers are increasing because remember, electrons are negative. When elements are being reduced, they are gaining electrons. But what that means for the oxidation number, since gaining electrons makes you more negative, that means the oxidation number is actually going to be decreasing. Let's go back to our sodium plus 1. If we go to just sodium 0, which was just neutral sodium, we would have to gain an electron to do this. Okay, so like I promised, we need new rules for assigning oxidation numbers. And like I said, you already know a lot of these. So you are going to need a periodic table. And if you do not have your periodic table yet, pause this video, Go get your periodic table. You must be looking at it while you're going through this. You can't just listen to me and be successful. Okay, you have your periodic table. Let's look at nitrogen. What's nitrogen's oxidation number? That's right, if we're looking at the periodic table, we would say that it's a -3. Let's look at sulfur. Sulfur, it's over in group 16. That's a -2. That's when we're just looking at the periodic table. Remember, we just look at the periodic table. Y'all know I love drawing periodic tables, and they always look terrible. Whoops, even more terrible than normal. But remember the oxidation numbers. If we had group numbers, 1, 2, 13 through 17, group 18, and we counted the oxidation numbers, -1, +1, +2, +3, +4, plus or -4, -3, -2, -1, 0. Remember that? That's where I'm getting that -3 and that -2. Now, that's still going to stay true some of the time. Let's look at some exceptions. Okay, so number 1, all free elements are going to be given a 0. Free element, that means an element that does not have a charge on it. So if I wrote sodium or magnesium or hydrogen gas. Now remember, hydrogen's diatomic, so that 2, that shows us that it's in its elemental form. All of these are going to have an oxidation number of 0. All free elements, oxidation number of 0. Now, if you have an ion and its charge is listed, use that listed charge. A lot of times we'll have iron. It'll say a +2. Well, dang it, that's a +2. Or if we've got gold and it's saying it's a +1, then it's a +1. Use the charge that listed for ions. Sometimes that'll happen. Now, this is what you're going to need to use when you're in that last stage of figuring some of them out. I've got rules and exceptions for a lot of the periodic table, but there's some that I don't, and you just have to figure it out. Well, while you're on your journey of figuring it out, this rule will be very, 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 very handy. Neutral compounds must equal 0. So if you have elements locked up into a compound, let's just say sodium chloride, the compound as a whole has an oxidation number of 0. So if you know one of these and you don't know the other, you could figure it out. Or even, so ionic compounds like sodium chloride, they're always going to equal 0, and we've learned that. Covalent compounds, let's say water, we don't normally think about those as having charges. Well, that has changed. All neutral compounds, and we're going to assume that all compounds are neutral unless they have a charge on them. We're going to say that their overall oxidation is a 0. I'm going to come back to that rule when we're practicing. The sum for your polyatomic ion equals its charge. For example, if I am looking at phosphate, if I add up the oxidation number of phosphorus and the oxidation number for oxygen, it's going to have to equal this -3. It's not going to equal 0 because we're not talking about a neutral compound. Polyatomic ions have a charge, okay? I don't want to go through this example just quite yet because we're going to do that in just a second. And I want to get through all these rules without bogging you down. So the sum of the polyatomic ion, we're going to have to be using that. So if you need your polyatomic ion chart, maybe now's a good time to pause the video and go and get that too. Hydrogen. We're to our first big exception. And it's really not that big. Hydrogen's in group 1. So hydrogen almost always has a +1, just like everything in group 1. There is one small exception though. When it is the only element following a metal, so if we have a metal and then hydrogen, hydrogen is going to be a -1. So if we had sodium hydride, this hydrogen is going to be a 1. Let's say we've got magnesium hydride. That H is going to be a -1. So hydrogen, most of the time, is going to be this +1. Unless you have a metal and then hydrogen, then you're going to get this -1. That's our first big exception. Oxygen is going to be our second big exception. Now, oxygen is in group 16, and it is almost always that -2. Okay, so we have oxygen gas, O2. We could also have O2 -2. That's the polyatomic ion peroxide. And we know that because of this charge here. If you have that polyatomic ion peroxide, then oxygen, each of the oxygens has to be a -1. Okay, so oxygen, most normally this -2. Oxygen gas, This is going to be in its elemental form. That's going to be a 0. Peroxide, each of these oxygens are going to be a -1. If we have a -1 and a -1, that gets us, it's our -2. That's an exception for oxygen. We've got another exception for oxygen. Sometimes you get oxygen and it's bonded to 2 fluorines. Well, fluorine is the most electronegative element on the periodic table. And so fluorine is going to steal that negative spot. Remember way back when we talked about ionic compounds having a positive spot and a negative spot? We're back to that. We're assuming every single compound has a positive spot and a negative spot. And so even though this is a covalent compound, oxygen at this moment is residing in the positive spot because fluorine is the most electronegative, so it must be in the most negative spot. So if fluorine is going to be negative, oxygen has to be positive. So, and it's only when fluorine's involved, because fluorine is the only element that is more electronegative than oxygen. So if we have OF2, oxygen's oxidation number is a +2. Okay, so that was a lot. Oxygen, normally -2, unless it's with peroxide. Peroxide is a -1. Each oxygen in peroxide is a -1. When oxygen is with 2 fluorines, it's a +2. I think as we go through practices, you'll kind of see that, and you won't even need to memorize this rule. Okay, now this goes back to our old rules. Everything in group 1, that's going to be a +1. Everything in group 2, that's going to be a +2. And aluminum, that's going to be a +3. Now, every once in a while, a previous rule or an exception that we've just learned will take precedence over this +1, +2, +3. And when that happens, you've got to go with the new rule. But for the most part, group 1 is always +1, group 2 is always +2, and aluminum is always +3. Okay, I'm almost through with all these rules. Group 17 and fluorine. You know, fluorine is a halogen. It is in group 17. But fluorine is the only one that we will say is always a -1. Group 17, almost always a -1, unless you have another group 17 element with fluorine. Anytime fluorine is involved, it's always a -1. So let's just say, for example, you had a chlorine and a fluorine. I just made that up. I bet that doesn't even exist. Fluorine would be in the negative seat, so chlorine would now be in the positive seat because all compounds are to be assumed neutral. So group 17, almost always -1, unless it's with fluorine, then fluorine must always take that negative role. We've already said this, but I wanted to make sure and say this again. Covalent compounds, the most electronegative is the negative. And remember, if we're looking at the periodic table, I'm just going to draw a tiny little bitty one. Fluorine is off over here, most electronegative. So the one closest to fluorine will always be the negative, and the one farther away from fluorine will be the positive for covalent compounds. And then our last rule is just, if I didn't give you a rule, you're just going to figure it out. Let's practice. So we've got a polyatomic ion. I see that charge right here. So I know that the total of all of these has to equal a -1. I also know hydrogen, always a +1 unless there's a metal in front of it, and there's not one. I also know oxygen is a -2. Now I've got to figure carbon out. So I've got 3 -2s. So I can say that that feels like a -6. And then I've only got 1 hydrogen, so that's a +1. So basically, I am going to have to use my logic just a little bit to figure out carbon. What do I have to do to this mathematical equation to where -1 is the answer? So if I've got -6 on this side, I really need this side here to be +5. Correct? That'll get me my -1. And I've already got this 1 taken care of. So I need +4. Do we see that? So carbon is going to be +4. If you're like, kind of saw what you were doing, then keep going forward with me. If you were like, what? Rewind and watch that one more time. Okay, here's another one. This is going to be neutral. I know this is going to be neutral because there is no number here. Okay, so let's just look through this. Copper. That's a transition metal. We don't know its oxidation number. Oxygen, though. Oxygen's always a -2. Hydrogen. Hydrogen is always a +1 unless it immediately follows a metal, and it doesn't. It immediately follows oxygen. Okay? I know this whole thing is going to equal 0. So let's see what we've got so far. I'm going to redo these numbers because I want my positives to go in front of my negatives. So I've got a -2 here. I've got a +1 here. And I've got something that I don't know. Hopefully you're already shouting to your computer screen what the answer is going to be. If I've got -2, I need this to equal a +2. So this can be 0. I've already got this 1, so I've got to put a +1 here. Copper in this instance is a +1. So copper is a +1, oxygen is a -2, hydrogen is a +1. Here's another neutral compound, again because there's no oxidation number here. First of all, I'm going to notice that calcium is a group 2 metal. Group 2 metals are almost always a +2. So I know this whole thing needs to equal 0. At this moment, I have +6 because I've got 3 calciums. Now, I'm going to kind of step back because I've got to figure out phosphorus and oxygen. Oxygen, always that -2 unless it's with fluorine or unless it's peroxide. And it's not in this case. But I also need to remember that phosphate is a -3. Okay, so I'm going to ignore this 2 for the moment. And I am going to say, okay, phosphate, I've got -2 and I've got 4 of them. That's a -8. I need it to equal a -3. So what must phosphorus be? Phosphorus is a +5. Are we seeing that? So phosphorus is a +5. Does that work out? +5 -8 -3. Good. -3. We have 2 of -3s, so that's a -6, and that gets us our 0. You just got to use just a little bit of logic. Let's look at this polyatomic ion. Again, I know it's a polyatomic ion because I've got that charge. That means the whole thing has to equal a -1. If you haven't noticed yet, if oxygen is there, that's what I label first, oxygen, -2. I have 4 of them, so that's like saying a -8. So what must my chlorine be if I want the whole thing to be a -1, +7. Hopefully these are starting to get a little bit easier for you. Okay, so let's try this one. Manganese is a transition metal. I don't want to start there because I don't know its charge. Sulfate, I know sulfate is a -2. Now remember, this whole thing has to equal 0. So when I put my -2 up here for oxygen, that gets me that 6. So what must sulfur be if we're going to get that -2? Hopefully you're thinking +4. Now, if this whole thing equals a -2, and we know that it's got to equal a 0, then manganese must equal a +2. Or we could think about that a slightly different way. We could say, okay, I've got 3 -2s, that's a -6. I got a +4. What must manganese be to equal 0? And again, that would be +2. 2 different ways you could think about that. Okay, let's do that last example. Okay, I've got iron nitrite. This is going to equal 0, but we need to remember that nitrite is a -1. Okay, so I always start with oxygen. Oxygen is a -2, but I've got 2 of them, so that's like a -4. So what must nitrogen be if I want my nitrite to be -1? Okay, so hopefully you're thinking about a +5. And if nitrite as a whole is -1, then iron has to be a +1. If we wanted to look at it that secondary way that I suggested, we've got 2 -2s, that's a -4. We've got a +5, that's got to equal 0, so what must go here? See what I'm talking about? That was a little bit different than the way we normally assign oxidation numbers. But there's not too many new rules. Make sure you stay tuned. We still need to figure out how to decide which half of the reaction is oxidation and which half of the reaction is reduction. Until next time, bye y'all.